The Arduino code for generation of the 10 hertz frequency, that the frequency that the 10 hertz is available at the PWM pin, that is the 10 number at the Arduino Uno, and to set the frequency we use the set pin frequency safe PWM 10, and there is the extra code that is not executed in the loop, and we are going to write the duty, that is the 139 is of 255, or we can say 54.3 percentage. Now the signal that is given by this cable to the Arduino board, the Arduino Uno, and this is the driver circuit
of MOSFET
using IR2110, that is the international rectifier IC, and we using CFR, carbon film resistance, and parallel, or we can say anti-parallel resistance. We generate the duty, or we can say the circuit diagram for this. So the PWM signal is given to the pin number 12, and output is available between pin number 1 and the ground, that is the pin number of 2. There is a two kind of supply, that is the 15 volt that is generated, we can say we draw this supply from the power regulated supply, and 5 volt to run the IC. To run IC we need positive 5 voltage, and to obtain the voltage waveform we use the 15 volt. Okay. Now the diode UF, ultra frequency or high frequency, or we can say high recovery diode, is used to turn off the MOSFET suddenly, and 10 kilo ohm is used to hold the voltage across the gate with respect to source of the MOSFET. Okay, now this is the resultant duty we can set at hertz, and press the button duty oblique hertz if we want to view the frequency. We press this, and now for duty again press this. The percentage duty is available. Now to see this kind of the waveform on the CRO screen, we use the CRO.
The output waveform of the PWM signal is shown by the CRO. It has the frequency of 10 Hz and the duty cycle is around 54%.
54 point something
percent of the input signal that is coming from the Arduino, that is PWM pin, whatever it is, number 5 or 6.
Okay. Now to check this waveform is capable to drive the MOSFET or not, we apply this generated PWM signal to the gate of the MOSFET. For the testing purpose we use the MOSFET IRF840.
It is a power MOSFET.
The power MOSFET, and we connect this MOSFET to a separate power supply like this.
This is the data sheet of the MOSFET.
Like this is the power supply, we can say that is the 12 volt, and this is the bulb, and this is the terminal for MOSFET. This is the drain, this is the gate, and this is the source terminal. Source is connected to ground, and this is the IRF 840 power MOSFET. Okay, now signal to the gate is derived from this driver circuit, and the result is that this bulb, it fluctuating at the 10 Hertz frequency for the testing purpose, because if we set the frequency at the 10 kilohertz, it is difficult to visualize or to see the result of required frequency, it is correct or not, because at 10 Hertz it is not possible to visualize or to see by the nude eye. So to see the on or off process of the MOSFET, we set the 10 Hertz frequency for experiment purpose, but in our project we set the frequency at the 10 kilohertz. That is also tested on CRO, or we can say using the digital multimeter, but visualization or looking on a process is not possible at 10 kilohertz. So to set the 10 kilohertz frequency, we can change the program like this. At this line, set pin frequency safe bracket PWM, that is indicating the pin number, and the second parameter or second argument of this indicating the frequency. Now we can set the 10 kilohertz frequency like 10 kilohertz. So that 100, the 1000 in 10,000 frequency. Now we can compile this program. Sometime the computer may give you error, but today's luck giving correct. Now I am loading this program to the Arduino Uno. This is the error, but I am trying again. This is the 100% success. So the bulb is continuous, because it is not, because at 10 kilohertz it is difficult to visualize, or we can check the frequency. There is the again duty 53.9, and to check the frequency it is correct or not, it is 9.995 kilohertz. This is correct because we want to set the frequency at the 10 kilohertz. So in practical 9.99, that can be considered as 10 kilohertz. Now the waveform on the CRO screen for 10 kilohertz, you can see.
So this is the waveform showing of the 10 kilohertz frequency, duty of 54 point something %. The incoming signal, that is the PWM signal coming from the Arduino. So this is a quite good waveform of the duty cycle. Okay, so by zooming it, now increasing the intensity, it will look something like this. So its duty is almost 54 point so on. That's it.
If we want to sense the temperature of IRA or MOSFET or the driver, it is very cool. No need to support or connect the heatsink parallel to MOSFET or the driver circuit. But in case of the DC-DC converter, we should use the heatsink to support the MOSFET, or we can say to prevent the high rise of temperature. Okay, thank you.